Now we're going to do the last two problems on this page. 4 is an awful lot like 2. It's just solving for something different. And then 5 is actually something important. If you haven't solved them, go ahead and pause the video and try it yourself. So in this one, what I'm trying to solve for is my temperature. Let's see. This is another one where it gives me my grams, but it also gives me the molar mass. So 41.6 grams times 28.02 grams in 1 mole. The volume is 20.0 liters. And then the pressure, that pressure unit is not right. Hopefully you saw that. 815 torr times, and I know I happen to already know this one. You probably would have to refer back to the first page, which is fine. But there are 760 torrs in an ATM. Both of the things that have 4 letters, there's TORR and there's also MMHG. Both of those are 760 in 1 ATM. All right, so now I'm going to just fill it all out. Notice that my temperature will come out in Kelvin, because that's where we've had to be converting everything into Kelvin, so my final temperature will turn out to be in Kelvin. I'm going to divide both sides by N and R because I need T by itself. I'm actually going to fill it in up here. So I want PV. So T is equal to PV over N over R. So my P is 815 torr. And then I know that I'm doing that times 760 torr in 1 ATM. And I'm just putting parentheses not because they are needed, but to separate out. So it's obvious that that's the pressure part. Here's my volume is 20.0 liters. My N value is this 4.6 times 2841.6. Having an issue with this, aren't I? So don't make my mistakes. 28.02 grams in 1 mole. That'll give me to moles. That's the mole part. And then R, 0.0821 liters. ATM. Mole, Kelvin. So that's liters canceling with liters. And then my torr is canceling with torrs. Then my ATM cancels with this ATM. My grams cancel and my moles cancel. That's a lot of canceling. So my final temperature is, and I'm going to put the calculator over here. Again, you only need parentheses if you are adding or subtracting. So I'm not putting parentheses in this. So 815 divided by 760. Well, you also need parentheses on the bottom. You do need parentheses on the bottom if, depending on how you put in the calculator. I should have clarified that. Divided by. Now, this is how I'm going to put this in the calculator. 41.6 divided by 28.02. So that's that term. And then I'm going to use my divided by sign again and put 0.0821. You could have also just used a single divided by and then like a big parentheses around that, and that's fine also. Regardless, hopefully you would have gotten 175.956, and that is everything I'm seeing in here. I have 1, 2, 3 sig figs, 1, 2, 3, 1, 2, 3. Yeah. So this is going to be here, but this rounds him up to 176 Kelvin. Oops, sorry. Throw him out. And this last one is pretty important. So there's a term called standard temperature and pressure, and it's just a lazy way of writing a problem in a way. It also is a way for us to standardize at what temperature and pressure we run a lot of gas phase reactions for data that go into journals and into like indexes of constants and things like that. STP, if you see a problem that says STP, see add STP. What that means is, hey, we're not going to tell you, but here's the temperature it was run at, and here's the pressure. So the new thing to memorize, STP for gases. Oh, by the way, there's going to be a standard temperature. There's a standard temperature pressure for energy, which is the next chapter also, but it's not called STP. So anyways, so that's what this means on the side. So it's asking what volume does 1 mole of a gas occupy. So PV equals nRT. And again, the pressure is because at STP, that's what that means, 1.00 atm. The volume is what we're solving for. It says 1 mole. And our R value we know. And then the T value is the 273.15 Kelvin. So PV equals nRT. We're going to solve for V. So that gives us 1 mole times 0.0821 liters atm. Moles Kelvin times my temperature, which is this 273.15 Kelvin, divided by my pressure, which is 1.00 atm. So really, I can put the ones in, but they're not going to change the answer. I can do 1 times 0.0821 times 273.15 divided by 1 again. So those ones parts don't matter. This comes out to be 22.4. There's 1, 2, 3 sig figs right there. Notice there's like a 4 too, but the 4 does not round it up. So 22.4 liters. So those are some example problems of how you can use the ideal gas law. So you're going to get a lot of practice with the ideal gas law in the homework section. Make sure you do it so that you're really, really comfortable working with it.